This
Close of
conference will now be
invitation.
recorded.
Uh, Sorry. Can you guys listen? Okay. All right. This is a great honor for me to accept and to participate in this sharing session. So the topic of the today's presentation is recent development of reconfigurable antennas in MIMO for future wireless communication system. Before I start, maybe I would like to inform everyone if you guys have any question, you just open your mic and interrupt my presentation. I am okay with that. Okay, so I will start the presentation today, the sharing session, with a brief introduction about myself. Uh, my name is Muhammad Nasrun bin Osman. You may call me Nasrun. Currently, I'm holding a position of Deputy Dean, Student Affairs and Alumni at School of Computer and Communication Engineering, UNIMAP. So I'm the senior lecturer at UNIMAP currently. I did PhD degree in electrical engineering at UTM Skudai, graduated in 2016, and before that, first degree in UTM Skudai as well, graduated in 2010. So I joined UNIMAP 2016. Now it's more than 4 years I've been served at UNIMAP. My research expertise is on reconfigurable antennas using RF switches for MIMO application. So apart from that, I also did a research on polarization reconfigurable antenna or circular polarization antenna, wideband antenna, wireless sensor networks, and etc. Anything related to communication, that area is my expertise. All right. So currently, I have published a few articles, 17 journals, nearly 30 conference papers, 2 book chapters. Um, I have a total grant of 110,000 as a lead researcher currently, and a total of 170,000 as a co-researcher. Um, and the good things I would like to share is maybe some of the senior staff might recognize me. Actually, I am a ex-staff of MCMC. I've been served at MCMC for two years and 4 months under USP division. I think the name now have been changed, but uh, I am in charge on computer netbook satu Malaysia, netbook satu Malaysia, Kampung Wi-Fi, CBC, CBL, etc. My ex-boss was arwah Encik Syafi'i and arwah Encik Uze. Both of I have learned a lot from them. So saya anggap they are like a mentor for me. Even until now, I still keep how we call MCMC ID stuff with me until now in my wallet. So my staff ID is 624. Just to show that MCMC is still have a place in my heart lah. This is my first job at MCMC. I've learned a lot from them. So I really owe a lot from I've owe and learned a lot from MCMC. Okay. So to start, this is the table of content for today's presentation. So we explain about the reconfigurable antennas in MIMO and 5G, and then explanation on the smart antenna and reconfigurable beam antenna, to touch on the design of the reconfigurable antenna properties, and then next MIMO and massive MIMO, and conclude by the future trend and the consideration for the 5G, especially for antenna perspective, antenna point of view. All right, I think this is a good platform for me before I proceed with the topic today to just a brief promotion and introduction about Unimap itself. Um, so we are established at 2001, May 2001, previously known as KUKUM, College Universiti Kejuruteraan Utara Malaysia, and then converted and upgraded to full university, rebranded to full university on 2006-2007. So until now, for full university, the age is about 14 years old university. We are focused universities focusing on electronic EE, electrical and electronics. Unimap is a public university, number 17, and roughly we have now more than 14,000 students. Unimap is a distributed campus, which means we have 3 campuses in Perlis to cover 3 district or 3 parliamentary area. The first one is at Pau, at Arau. This is our main campus. We call it Campus Alam at Pau, which to cater engineering courses. And then we also have at Padang Besar, University Sungai Sucuh campus. This one to cater the program of diploma and also engineering technology campus. And lastly, we also have a campus at Kanga to cater the program of business, non-engineering program, business as well new media campus. This is our recent achievement. We have a new entry in ASEAN institution. This has just been released by World University Ranking by Time Higher Education, and even this is our new entry, our first time to enter top 1,000 universities in the world. And in terms of the young university ranking, we are at 450 to 200 rank. So this is a good achievement by Unimap, considering we are just less than 15 years old universities. All right. So to start, I will start with the evolution of the mobile communication itself, where we have started with 1G technology, 2G, 3G, 4G, and moving forward, we are going to have 5G technology. As maybe we can recall, in 1G technology is just analog devices, and then digital coming in at 2G, where we can have a services, some sort like the speed is very slow, but we can have a MMS, okay, multimedia can support a very minimum multimedia. You have 2.5G at GPRS, and then we have 2.75G for edge technology. Move to 3G to support more multimedia. The speed is about 2 meg. From here, we have a good speed. We can browse some internet with a good speed, and then move to 4G. This is where we are now, where we have our smartphones, and then we can enjoy better speed. And moving forward in 2020 and after this, when it comes to IoT worlds, so we need 5G to support more multimedia, to support more devices, to give a better internet access to the user. So when we are talking about 5G technology, there are 5 foundations, 5 elements that have to cover. The first one is the millimeter wave. We are talking about high frequency spectrum, more than 34 gigahertz, more than 30 gigahertz. Small cells, massive MIMO. This is the topic of today presentation. And beamforming again, and full duplex. So the one that I highlight here, rectangular, the red box, is the one that we are covered today, which is another 2 important aspects in 5G technology. Again, evolution of beyond 3G technology. After this, the antenna as our mobile phone and also antenna at the base station will be accommodated with MIMO technology and also beamforming element. Instead of just a fixed element or just a array antenna at the traditional sectors antennas at the base station, now the antenna will be MIMO and beamforming antenna. Okay, and even in terms of theoretical part, if you want to improve, there is a demand currently. There is a demand from the users to have a good speed or good capacity. And according to Shannon-Hartley theorem, if you want to have a good speed, you have to either increase the bandwidth or increase the signal to noise ratio. But if you want to increase the bandwidth, we have to have the largest spectrum. And as we all know, MCMC own the licensing for the spectrum. The spectrum is limited, the first one. And the second one, the spectrum is very cost. It's very expensive. And to use this technique is not suitable. So there is another way where we can improve the signal to noise ratio. To improve the signal to noise ratio is either we can apply a higher order modulation of by having a increased number of bit per symbols. This is the first one. And the second one, we may have a MIMO technology applied to the system. If we're having MIMO, we can improve the signal to noise ratio, and obviously we may improve the speed of the system. And to further improve the capacity, the reconfigurable antennas is deployed in the MIMO system. MIMO can improve the signal to noise ratio. We can further improve the system by having combination of MIMO with reconfigurable antennas. Okay, I would like to show, just to give a brief idea to all the participants here. This is a video from Nokia. Okay, let's watch this. Hopefully, okay, that is a brief introduction about MIMO and beamforming, which I'm going to touch in details after this. Okay, so these are a few articles which the needs of millimeter wave or reconfigurable antennas and in the 5G technology. This is articles by FCC released in 2014. FCC explores new technologies that could unlock higher frequency spectrum. So we are talking about millimeter wave spectrum. And then in the article by National 5G Task Force report, 5G key challenges. One of it is in the research innovation, item number 3. We highlighted here energy consumption optimization, where advanced MIMO and beamforming techniques could help to focus the energy usage where it matters. So it shows the importance of reconfigurable antennas in a 5G technology later on when we can apply these techniques to have a more energy consumption optimization. Another press release in 2014 by Ericsson and IBM, they highlighted here that the phase array design allows for more directional antennas that are electrically steerable. This is the word, electrically steerable, meaning that the antenna is not fixed anymore, it's a reconfigurable antennas, where the pattern of it, the radiation pattern of the antenna can be steerable, can be moved, can be changed, can be modified. This is another statement by the Samsung itself. Even Samsung has announced world first 5G millimeter wave mobile technology. Samsung plans to accelerate the research and development of 5G mobile communication technology, including adaptive array transceiver. So again, it comes to adaptive array related to reconfigurable antennas. So these articles, another articles is by Theodore S. Rapaport. Future cellular networks could exploit the huge bandwidth available in millimeter wave spectrum. Okay. So to continue on this, an additive array of 64 tiny antenna, each about the size of aspirin tablet, form the heart of millimeter wave transceivers used in Samsung 5G wireless prototypes. Again, this one just to highlight that the steerable antennas or reconfigurable antennas play an important role in 5G technology. The same thing here, to steer and track multi-user beams for multiples frequency deviation MIMO. So the base station by using a beam elevation beamforming or azimuth beamforming antenna. All right. So it might come to a question why reconfigurable is so important in 5G technology. The first one is it may support it's more than one wireless application. Second one, it can give a lower front end processing. The third one is a best candidate for software defined radio. And the third or fourth one is a multifunctional capabilities as compared to a fixed antenna. It provides a fixed properties. There is no adaptability to a new environment, to a new scenarios. But by having a reconfigurability antennas, we can have a special features. We can have a special reconfigurability to adapt to a new scenario and to give a better performance as compared to a fixed and traditional antennas. So it can support more than wireless application. Obviously, it can minimize the cost. We have good isolation and simplifies integration. Lower front end processing, no need filtering process and good band rejection. You may use for the connective radio application. Obviously, it can have a change of functionality from the single and array. So to touch in details about reconfigurable antenna properties, actually there are three types. Actually there are four, but the number four is a combination of those. But we have three. So the first one is frequency reconfigurable antennas. The antennas have the capability to be switched between wideband to narrowband. From this result, you can see that they have a multiple narrow band, which this one can be switched from one band to another band. We also have the one that we are very interested into is the pattern reconfigurable antenna, beam steering or beam shaping, where the beam can be directed to the user instead of directed to some areas. Now it's directed to the user to provide better efficiency and to provide better performance. The third one is the polarization. It can be changed into linear to scalar polarization or between vertical to horizontal polarization. Okay, so reconfigurable antennas play an important role in connected radio application. It provides a UWB antenna to do a sensing, and then interwave scenario to have a narrowband sensing as well by using a reconfigurable narrows antenna. This is example. This paper published in 2014. Frequency reconfigurable antennas where this design have produced a wideband sensing antenna here, and then frequency reconfigurable communicating antennas in here. By having two switches, switch 1 and switch 2, this one can have the frequency reconfigurable antenna. And another example is published just recently in 2020 in IEEE transaction. This one used varietal diode to have a frequency tuning. This result shows the S parameter results for wideband application from 1 gig to 5 gig. And then within that, there are many, but I just crop few results here to show to you. There are narrowband frequency in the middle of these wideband operations. So here we have at 0.42, for example, and then 0.5, and then 0.58, 0.62, 0.68, and many more. So by controlling the switch, controlling the variator diodes, we may have an antenna which provide a wideband characteristic and also narrowband characteristics depending on our application. Another example is published in 2020, recent published. This one use SIW technology, substrates integrated waveguide technology, and a pin diode to switch the frequency of it. This is the biasing mechanism. This is the structure where from the result itself we can notice that the frequency operation of the antenna has been switched from one to another. Okay, this frequency reconfigurable antennas is very suitable for cognitive radio application later on. Okay, second one, we move to the polarization reconfigurable antennas. What is meant by polarization is when the antenna itself, when it propagates, the signal propagates out of the antennas, it have the polarization. And there are three types. It's either linear or circular. It's either linear or it's a circular polarization or it's elliptic polarization as shown in the illustration here. Okay. So the antenna is propagates by having this kind of polarization. And by utilizing these properties, the system may have a better performance. This is the first one, polarization reconfigurable magnetoelectric dipole antennas for 5G Wi-Fi. They have controlling of dipole antennas by having a switches in the middle, reconfigurable antennas. The antennas can be changed between linear to circular. And circular also we have two. It's either anti-clockwise or clockwise. It can be rotated clockwise or rotated anti-clockwise. So having those two and with linear polarization will provide additional features to the system. This is actually my design, my PhD design. I have a MIMO 2 ports, and then this design is actually capable to be a switch between orthogonal linear polarization and orthogonal circular polarization. And even this one has been published in 2015, if I'm not mistaken, at AWPL, IEEE AWPL. And even we have conduct an experiment, setup and scenario to show the benefits of reconfigurable antennas, especially in a non-light of sight scenario, in a multipass environment. A simple analogy of this multipass environment is indoor scenario. I believe everyone in their house have their Wi-Fi. you may enjoy a better speed when you are sitting close to the router. But if you are sitting, especially router in the first floor and your house is you have a second floor, you might have a signal degradation. But by having antenna with polarization reconfigurable antennas, uh, this one can be exploited. We can have a switch of the polarization to give a better performance to the user. And the circular polarization is very important in the multi-pass environment because of the circular polarization properties of it, where it can receive any signal coming, any angle signal coming. This is the reason why the antenna for the GPS is a circular polarization. So one example of circular polarization, the antenna for the GPS. So GPS antennas, we have circular polarization because if using linear, there is a possibility that there is a polarization mismatch between those terminals, between transmitted and receiver antennas. If there is a polarization mismatch, polarization mismatch means that if the antenna transmit with vertical, but your antenna receive in horizontal, this is orthogonal. When it's orthogonal, there is no communication. There is possibly no communication at all between those two. So good communication if this one talking with vertical and the receiver also with vertical, and then you can have a polarization matching. But if you have a horizontal, if you have a circular polarization, even the antennas, the transmitter antenna is vertical or horizontal or slanted, it can be received by a circular polarization antenna. Okay, so this year we have conduct this experiment. Um, indoor scenario in the lab, and we also provide in the middle of the between receiver and transmitter, we have put a blocking just to show that between receiver and transmitter there is a non-line of sight scenario. And here where this polarization reconfigurability will play their role to give a better speed. Okay, this is the findings of that. The one that I highlighted in the box shows a positive. Positive means it can improve the channel capacity. Okay, so in certain scenario, I'm not saying that all of the antenna will provide um, um, a better performance, but it's depending on the scenario and depending on the location. um, as compared to a non-reconfigurable antennas and a reconfigurable antennas, it may improve up to 50% of the channel capacity as compared to non-reconfigurable antennas. You just imagine if the antenna is smart enough, if you move from one point to another point inside your house, the polarization of antenna will be switched automatically to find the best polarization for that particular location, for that particular scenario. As compared to now, it's just a polarization is fixed. When it's fixed, it just give whatever polarization is fixed. It's a linear polarization. But if this polarization reconfigurability is been deployed in that system, it can further improve the performance of the system. Okay. Um, Finish on that. So then we move on pattern reconfigurable antennas. For the pattern reconfigurable antennas, antenna itself have its radiation pattern. Its a pattern. Its a pattern is either omnidirectional for dipole. Maybe this is the common antenna being used for router in our router in our house. It's just monopole antennas or some by using a dipole antennas. Um, uh, Previous in our car radio is a monopole antennas. Maybe before this we are using uh, antennas for our home. Before this, it's like maybe we call it in our house before this. Previously we call it a tulang ikan antenna. It's called it the technical name is a Yagi Uda antennas. So this is also another type of antennas. So each of the antennas actually they have their own radiation pattern. They have their own radiation pattern. So usually this pattern is fixed. If I'm directed towards the PC right now, this is just fixed. But if you can have a pattern reconfigurable, meaning that we can have a beam towards this and we can also have a beam towards any direction that we design. Maybe 30 degree, and then 60 degree, 90 degree. This beam can be steerable, can be shaped. From here you can see we have this is the design published by my team. We can have a reconfigurable antenna pattern towards this direction, or towards this direction, or going upwards, going this one, going to the left, and going to downwards. So we can have a beam shaping instead of one fixed. Now it can be shaping. The same thing here, similar techniques. We can have beam shaping antennas by utilizing a parasitic techniques. We can have a beam shaping at the 0 degree, and then up to 40 degree left and right. This, another examples of pattern reconfigurable antennas, as you can see from these figures, it can go to the left, go to the middle, and go to the right. Even to the right here, there is a difference in terms of the angle and the gain of the antenna itself. So it may provide a better performance. As the simple analogy of it is, you have one user, instead of you have a more omnidirectional antenna to cover all. Now we can provide a specific beam to specific users, which this one can give a good radiation efficiencies, which increase signal to noise ratio and will increase the channel capacity. All right. Another example of it by using pixel antennas. This is also part of my team research. Recent research, we have using pixel antennas. From that, we can have pattern reconfigurable antennas. It's not just that the fourth category will be the combination of all. There might be an antenna where have a combination of frequency and polarization, or frequency with a pattern, or pattern with polarization. By having that, we can have more flexibility by the antenna itself. This is an example of it. Have a pattern reconfigurable antennas by using the same technique, but by creating a slot behind on the ground plane, we may change the frequency as well. So this particular design having frequency reconfigurable antennas and also pattern reconfigurable antennas at the same time with the same structure. Same here, we can have a polarization reconfigurable antennas together with a frequency. By having this, we can have a frequency changing and also polarization changing on the same time to cover GPS or to cover wireless line or GSM spectrum. Okay, so we have done on the reconfigurable antennas. So we move on to the MIMO and the massive MIMO. Um, um, Before I start, just a simple analogy of the MIMO itself. It will give independent stream between transmitter and receiver. Meaning that a simple analogy of it, if we can have a highway, one lane, and highway with 4 lane, obviously highway with 4 lane will give you a better traffic flow. So the same analogy can be applied to a signal, to the wireless communication technology, whereby we can have a multiple independent stream between transmitter and receiver. Another analogy, if you want to capture as much as, for example, there is a raining, and you want to capture as much as raining drops, it's better for you to have more containers. Instead of one, you can put more containers, then you can capture more raindrops. So the same thing, if you can provide more antenna elements, or we are talking about 2x2 or 4x4 MIMO. This is in LTE, but moving forwards in 5G, we are talking about massive MIMO. Massive MIMO means the antenna might be more than 50 elements, 64, more than 100 elements. Okay, so in the 4G LTE cellular data, actually this MIMO has been applied. Even in the Wi-Fi technology, when you can see 802.11 AC, actually this one have been deployed with MIMO technology already, 802.11 AC. It can be 4x4 MIMO. Okay, where traditional antenna is just between one antennas communicate to one antennas. So we call here this one is 1x1 MIMO or SISO, single input, single output. But moving forwards, we are talking about 2x2 MIMO, 3x3 MIMOs, or 4x4 MIMO devices, where have four antennas, four data streams. And to exploit more, it's good if the transmitter and also the receiver part have both MIMO. If the receiver, for example, base station have 4x4 MIMO, our receiver, for example, our mobile phone also should have 2x2 MIMO or 4x4 MIMO. By having this, the system we can have a data speed maybe 2 times higher or 4 times higher than a traditional antennas. So this is the massive MIMO. The traditional MIMO, we have a 4G sectorized antennas. We have a sectorized antennas, but by having a 5G massive MIMO, after this for 5G technologies, the antenna elements inside inside the base station for one sectoring will be more than 100 elements. And for each of the elements will be narrowband directed to each user or to each particular location or for each particular levels. When that we are talking about a multi-story building, so there will be a specific beam towards the highest stories, and then to the middle stories and to the lower level of stories. So this one, but because having multiple antennas over there, we can have multiple beams. By controlling this, we can the massive MIMO can offer much better performance efficiencies as compared to just a 2x2 or 4x4 MIMO. This is another example of MIMO beamforming. This is the base station of the 5G. We can have a one beam directed to the car, another beam azimuth beamforming to the working users, and then we have multiple beams to tall buildings, multi-story buildings, and then another beam going to the residential areas. Okay, this is the idea of the beam forming. Instead of we just have one, previously it just have one beam going here, and then another beam going here, another beam going there. It's a 120 sectorized antenna. Beam forming may offer better as compared to just a sectorized antennas. Obviously, this is another example of a MIMO antenna for the smartphone. There are many researchers out there um, are doing a research on MIMO antenna in the mobile terminals. This example we have four antennas. We are not noticing this in our smartphone, but actually there are existing products by Samsung or iPhone where the antennas inside that phone actually is more than one. It's 2x2 or 4x4 MIMO. I will show to you some of the products. And below one here, there are 8 elements in one smartphone. Here it propose six elements, here also 8 elements. And obviously when we have more elements, we can provide more better performance. But in terms of the antennas research, we have to provide some of the result to show that this antenna is capable and usable to be used for 4G or 5G technology. Some of the properties, for example, isolation, um, reflection coefficient. These are some of the properties, some of the parameters that the researcher have to look into to see whether their design is good enough or not. And obviously, when we design for the mobile terminals, the researcher will be investigate the effect of the hand gesture when we hold our hand on the smartphone. What is the effect of it towards the performance of the MIMO antenna? Okay, this is another example where this design proposed 12 antenna elements, just a monopole antennas. And also they want this paper also investigate on the position that we hold our smartphone. Is either right hand or left hand, or suddenly sometimes we hold like this, and what is the effects of the radiation patterns of the antennas towards the performance of the MIMO. So based on this, the results and the findings of this analysis, the proposed one, the red one, have a better channel capacity as compared to 2x2 MIMO at frequency band, at the LTE frequency band. Okay. So these are some of the findings in MIMO, recent research in MIMO, and even some of the researchers, they are looking into the number of elements in our smartphone is not just 12. They are figuring now if we can offer more antennas. It's not just 12, maybe more than that in our smartphone for 5G technology, even for 6G technology after this. This is another example. This is one of the example existing product by Ericsson, Mid Air 6468. This is a massive MIMO antenna product ready, where from this data sheet of the antennas, the antenna is a 64 transmitter receiver. Okay, it has 64 elements in one antenna. Another example is by Huawei. Huawei also have claimed that they have launched a C-band 64 element and 32 element massive MIMO. So again, all of these big service providers, Huawei, Ericsson, they have moving towards the deploying MIMO, massive MIMO in their to be deployed in the base station for 5G after this. Okay, which they claim that they can provide 20 to 30 times increase in network capacity. All right. Another example, maybe you might see in this, some of the router, Wi-Fi router now, they are not just using a 2x2 or 4x4. It's more than that. If you want to buy a router after this, please check and ensure that the router is a 802.11 AC. This one will provide a better speed as compared to just a 3x3 MIMO. Maybe double or triple than that. Okay, so if have more antennas, maybe some of you might think this is just more antennas, but more antennas will provide more capacity. And another example, for Samsung Galaxy S9 or Samsung Galaxy S9 Plus, they are actually embedded with an enhanced 4x4 MIMO. Those user for those who have bought this model, you are actually using a MIMO already, 4x4 MIMO. And also for the user for iPhone XS or iPhone XS Max, they are also have a 4x4 MIMO embedded in the smartphone. So either iPhone or any Android phones, they are now moving forwards. The antenna itself is not just have one antenna or two antenna or four antenna. Might be some of the phone, if I'm not mistaken, some of the researchers have published the smartphone for 5G after this will be 8x8 MIMO antennas or 16 MIMO antennas. So more antennas, it can give you more much better, highest speed, internet speed. So as a user, we are very happy to enjoy more speed, because we are demanded for that. We want to use. We don't want to experience a lagging of when we are surfing for the internet. Okay. So if you are using these two models, and you compare to the antennas to the smartphone which is don't have this MIMO, you may enjoy better speed as compared to them. Obviously. Okay, obviously. Another example of a MIMO antenna, just pick two, where just to show that they can improve 80%, 5%, nearly 80%, improve 66%. So the use of MIMO antennas, it can improve the performance of the system either in a light outside or non-light outside scenarios. So this is, I believe this is the last slide. The future trend, obviously, in the future trend, they will add more functionality of the antenna itself. I'm just talking about the antenna perspective, from the antenna point of view. There are other things. Those are working on the modulation, those are working on signal processing. They have their own techniques to improve or to support for the 5G technology. But for the antenna perspective, to add more functionalities can give a better performance for the 5G technologies. But obviously, there will be a challenge. For example, what are the suitable techniques to apply for that? And what about the DC biasing? What kind of switches that we use for, especially for the millimeter wave application? Because we all know that when we are talking about higher frequency, the size of the element will be very small, because the wavelength and the frequency is inversely proportional. Higher frequency, small size. When we have small size, this is the challenge. And recent studies show that the antenna now, after this, will be in the chipset, very small in the chipset. Maybe in the one chipset can have 64 antenna elements inside that. So this is the challenge. But um, uh, in our perspective, research, there is still a 5G frequency band given at the middle band, 5 gigahertz of 3.5 gigahertz. This will give us additional freedom for us to design at the middle band frequency at 3.5 or 5 gigahertz band. This one very slightly lower. Obviously, when we have antenna with high frequency, it will have this particular frequency will be facing a problem, especially with the obstruction of any obstruction between the transmitter and receiver. If you have a wall or you have a tree, the signal might be absorbed by that. Or you have heavy rain, the signal might be absorbed by that. But if you can have a frequency reconfigurable antenna, if the signal at higher frequency, which provide or offer better internet speed, but being that signal, that particular frequency is not useful for that particular scenario or location, it can be switched back to 3.5 or 5 gigahertz, which is slightly lower frequency but better wavelength, high wavelength, that it can penetrate buildings or penetrate trees or penetrates heavy rain. So this is kind of functionalities or adaptabilities of the antennas that can be thinking of in the future. All right. I think that's all from me. Thank you so much for listening. I pass back to Puan Sharifah. Maybe we can have a Q&A session.
Yeah. Thank you, Doctor. Yeah, I think we can open to a few questions if there's any question from you.
Yeah. If you have any question.
Assalamualaikum. Assalamualaikum, Doktor. Baik Haki.
Ya, baik. Alhamdulillah. Apa khabar?
Allah, Doktor. Apa khabar, Doktor?
Kenal, jangan panggil doktor lah. Allah, kita kawan lah.
Maaf ya, Doktor. Segan lah ni. Rasa kerdil sangat ni. Ramai sangat dengar ni.
Jangan kedil. Ilmu ni luas.
PM tepi ni.
Boleh. Tanya sini boleh. PM tepi boleh. Mana-mana pun boleh.
Soalan mudah je. Dia macam ni. Kalau macam traditional punya antena, kita ada bercakap tentang alarm apa semua. Capacity, berapa traffic dekat dalam tu. Untuk massive MIMO ni macam mana? Contohnya bila dia ada specific person, dia tembak dia punya propagation dia tembak ke beam dia tu, dia tembak ke specific place, location ke level. macam mana dari segi kapasiti, macam dalam satu masa tu dia control dia punya user ataupun yang dekat dalam kawasan tu. Macam mana dia nak tahu dia tu? Macam dia punya adakah dia boleh increase daripada tradisional punya antena atau macam mana?
Okey, terima kasih Pak Hiki soalan. Saya jawab bahasa Melayu lah. Saya jawab. Okey, kawan lah. Boleh kawan-kawan. Dia macam ni, Pak Hiki. Bila satu antena, kalau contoh kita just ada very traditional antennas, kan? Kita akan ada antennas tu dia just akan point dekat one specific sectors. Okay, kalau user tu bergerak keluar daripada kawasan yang dia the density of the beam dekat situ dan dia bergerak keluar sikit, actually dia akan facing signal drop. Tapi the idea of the beam forming adalah dia akan ada very narrow band to one specific area. Okay, it's not just that. Kalau kita berada di kawasan yang kalau the user itself akan berada di kawasan yang dekat mana di situ the signal the density of the signal sangat tinggi di situ, dia akan enjoy the user akan have better signal to noise ratio. Dan kalau according to the theoretical part, kalau kita have better signal to noise ratio, dia akan better capacity. Sebab tu kalau the idea is after this dia akan ada not just beamforming, dia akan ada adaptive beamforming. Maksud dia beam tu akan follow user sampai dia keluar daripada coverage. Beam tu akan follow. For example, kalau awak berada di sini, beam tu sekarang duduk di sini. Kalau kita move, kita berjalan ataupun kita bergerak, beam tu akan follow kita. Sampailah kita keluar coverage, kita masuk tower kawasan baru, coverage tower baru, tower tu pula akan serve new beam kepada kita. This is the idea of adaptive beamforming. Kalau adaptive, obviously kita akan enjoy better speed. Sebenarnya idea dia adalah kalau satu beam directed to the user, specific for that user or specific for that particular location, dia akan have better performance.
Biasanya user untuk one beam forming tu boleh one user je ke ataupun dia ada
beamforming? It can cover it can be to one specific user or one particular group, or it can be to one specific area. Tapi very small. Sebelum ni mungkin kita cover 120 tu mungkin 120 degree sectorized antennas. So kita guna array antennas or kita guna monopole antennas. So kita akan cover di sini. Tapi kita kena faham dia ada beamwidth dia. Dia ada certain kawasan yang memang dia tak signal strength dekat situ sangat very low, tapi you still can connect. So kalau we move, actually kita dah degrade the signals. Actually we have, kalau kita berada di kawasan yang high beam dan kawasan yang slightly lower beam, sebenarnya kita dah in term of internet capacity kita akan drop sebenarnya. So kalau we have a beam or adaptive beam forming, one beam that can follow us or one particular beam that we can serve to us as a user actually can provide better speed lah. That's the idea. Sebab tu beamforming dengan adaptive beamforming is the criteria for 5G. Dia nak beam tu ikut terus user ataupun beam tu specific beam given to the user. Sebab tu elemen dia banyak. So 2 or 3 elemen pergi ke sini. Another element akan spesifik kepada sini. Another element akan pergi ke kawasan ni. Dia jadi macam tu. Instead of just one beam going to general kawasan kan, dia akan pergi kepada specific location lah. Cuma sekarang ni dia tak ada pergi specific user, dia akan pergi ke specific location tapi sangat small. Mungkin satu floor tu satu beam. Ataupun ground floor another beam. Lepas tu kawan yang berjalan another beam. Kereta another beam. Rumah another beam. Macam tu.
Okay, terima kasih doktor.
Okay, terima kasih Nasrul dah lah doktor apanya.
Thank you, Dr. Nasrul. I think we did a lot today on reconfigurable antennas, MIMO beamforming,
So hopefully this talk beneficial lah for some of you, hopefully. InsyaAllah.
Yeah, really. We will keep in touch and of course welcome to MCM lagi, KMRC datanglah.
InsyaAllah memang MCMC, as I mentioned, memang still in my heart lah. Ada place dia, ada kuasa, ada ruang dalam hati ni untuk MCMC. Yeah.
Okay, thank you again, Dr. So thank you to all yang join us today. Inshallah we'll meet again.
Okay, thank you
Okay, with that,
everyone.
yeah. Assalamualaikum.
Waalaikumsalam warahmatullahi. Thank you everyone.
Bye.
Bye.